Hi, and welcome to a video where I'm going to just do some bonus problems for Taylor series. And so here we have a question, and it says consider the derivative of f is cosine of x squared, and our job is to find a series for f of x. Now, I want you to separate out the fact that we are calling cosine of x squared a derivative. It is simply a function. We don't care what it's called, f prime, f double prime, f of x. It doesn't matter what we're calling it. It is a function. So anytime I'm asked to write a series and I'm given an equation, I'm going to disregard the f prime part, and I'm simply going to construct a Taylor series for the given function. So I'm going to use my Maclaurin series for cosine of x, because this is a composition situation. And so I'm going to start out 1 minus, and then I'm going to say x squared over 2 plus x squared to the 4th over 4 factorial minus x squared to the 6th over 6 factorial, dot, dot, dot. And I'm going to go all the way to that nth term where I alternate, and then I've got x squared to the 2n all over 2n factorial. So there's my cosine series. Now, I'm going to simplify this, because if I am calling this f prime, to find f, all I need to do is find the antiderivative. And I'm going to go term by term. And this is a polynomial, so I'm simply going to need to use the power rule. But before I can do that, I do need to simplify my exponents. Now, my nth term, I'm going to multiply. This is going to be x to the 4n all over 2n factorial. Now, when I go to find the series for f, all I have to do is do the antiderivative. And sometimes these problems do involve a little bit of chain rule and a little bit of u sub, so you do kind of have to be on the lookout for that. Really, we would need to look out for that if we had like a 2x inside, and so maybe we'll have another bonus video regarding u sub with Taylor series. But this one is pretty straightforward. And so to find if this is called f prime, then f of x is simply the antiderivative. So I'm going to do x minus x to the 5th over 5 times 2. And I can simplify that if I want to. X to the 9th over 9 times 4 factorial minus x to the 13th over 13 times 6 factorial. I'm just going to leave it, because unless I'm asked to simplify, there's really no real benefit to it. But then when I do this for n, remember, I'm just adding 1 to the exponent, and then I'm multiplying by that same number on the bottom. So I want you to treat n, think about n the way that we did with our numbers. What did we do with the 12 that made it a 13? Well, we took the 12 and we added 1. So we're going to take 4n and we're going to add 1 to that. And then we divided by that 13, so we're going to divide by that 4n plus 1. So n is just a number. So if you're ever worried about, well, what do I do with the n? Whatever you did in the term with a number, n is just the number. It's just an unknown number or an unspecified number. So this is how we can use these series to do problems like this that involve doing derivatives and antiderivatives. So here's bonus problem number 1 for you.